Okay, we are going to relate it with the geometry. We start with flat, slab, or wall. Okay, just like been shown to you in the previous slide. Okay, so but this one is much more specific now. Okay, when we talk about flat, slab, or wall, okay, it's very simple. But I have the one that I want to stress or to emphasize in this slide is driving force over resistance. Okay, it's good to conduct or to carry out the calculation, okay, based on ataupun the way you conduct the calculation. um, it is recommended to use this method, this approach, okay, whereby you have the original equation yang macam ni kan, you ada equation yang ni flux lah, ni flux ataupun kalau Q tu you ada equation yang ni lah. Okay, it's good to know that okay the equation dia bla 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 bla, tak ada masalah lah. Okay, tapi if basically kalau you, because we are not talking about this flat slab ni, sebenarnya flat slab ataupun flat wall ataupun plain wall ni. Okay, we are talking about kat depan-depan nanti yang akan lebih kompleks lagi dia punya calculation, whereby you have more than one R. Okay, this one is single R saja, satu R saja sebab ada satu wall, ada satu thickness saja. Mungkin ada 3, 4, 5 layer nanti. Okay, so it is better for you to have or to use this approach, meaning that you separate in between driving force and resistance. Okay, they express this equation, they categorize this equation into two things saja, two terms saja. One is being called driving force, which is strictly the temperature difference. Okay, and another one is being called resistance, which is um, other than the driving force, other than the temperature difference. Okay, for example, if you have this kind of equation, okay, uh, Q Q is equals to Ka over delta T over delta X kan. Okay, so delta T is driving force. So the rest is resistance. So in that case, delta X over Ka is the resistance. Okay? R is delta X over Ka. Okay? So it's better to do this approach lah. Okay, better to do this approach. Okay, and the unit of R is Kelvin per watt. Okay, so betul lah tu sebab this one unit dia meter. Okay, this one unit dia watt per meter dot Kelvin. Okay, so Kelvin dah meter Kelvin dah kat atas kan. Okay, so dan ni adalah meter square, so they cancel out meter to each other. Okay, so dia akan live with Kelvin per watt ataupun hour dot degree Fahrenheit over BTU lah. This one is British unit lah. Okay. So normally we will use this one lah, SI unit. Okay. So T1 minus T2 delta T. Okay. This one is the resistance. Okay. Conductivity and A lah. Okay. Okay. So for thermal conductivity, it varies with temperature. So this one is basically if you have from T1 ni to T2 ni, dia punya bila dia berubah temperature, dia punya K dia berubah. But most of the time we will assume that the system does not have any changes in conductivity. Okay, or rather there is no changes in the properties of the material along the way. Okay, normally we will assume that lah. If there is a changes, so for example the thermal conductivity, So this would be the formula lah, and you might want to use. Okay, so A and B will depends on the material. Okay, kalau copper tu ada nilai A dengan B dia sendiri. T1 and T2 is that particular temperature, specific temperature. Okay. And you have ni lah, KM ni lah dipanggil. Yang ni keseluruhan term ni we call it KM. Okay. KM, which signify the thermal conductivity based on that point temperature, the current temperature at that point of interest. Okay, so you can use this, but normally we can just abaikan saja. Okay. Right, let's do this exercise example. You have 3 times 5 area. Okay, dia punya area dia is 3 times 5. Okay, so it's 15 meters square, and the temperature is 16 and 2. Okay, so the delta T is only 14, and you have a length of 0.3. Okay, and then you have to determine your, sometimes the question only want you to compute the value of resistance. Okay, so this one is basically kalau you comparekan dengan resistor, so dia akan jadi satu resistor. Okay, that R value tu apa? Okay, so R value tu is delta X over K A. So you compute dulu R ni, okay, delta X by K A dulu, and then only then you can divide delta T with that R. Okay, so you will get 630 watt. Okay, so again, this is just like I have explained to you on the previous slide. So it's still straightforward lah, tak ada masalah apa pun. Hopefully tak ada masalah. Kalau ada masalah, beritahu lah. Okay, basically this one is to emphasize this approach. So please use this one. Okay, this approach. It's recommended lah to use this approach rather than you use full equation ni. Okay, ini pun sebenarnya dah mewakili dua-dua ni, dah sebenarnya dia dah simplify saja. Okay,